Hello, my name is Liam Hartley. I'm a senior at Milton Union High School, and my project tests how different wire materials that are made for coils and generators and the different rotational speeds of the magnetic rotor inside the generators affect the current output and how it performs. So I've hypothesized that if copper, aluminum, 316L stainless steel, and silver wire were used to create the coils in an AC generator, then the silver would perform the best, followed by copper, aluminum, and steel, because copper and silver are well known for being conductors and used in electronics. I also predicted that as you increase the RPM or rotational speed of the central magnetic rotor, the current that you would produce would increase logarithmically due to heat loss from the system and leaching away power in that respect. So for the materials, you need a magnetic rotor, which involves you having a magnetic setup that can spin along an axis. You need an iron core surrounded by coils of wire. I used about 25 feet for each of them in my experiment. And then you need to wind these coils out of the 28 gauge copper, silver, aluminum, and 316L stainless steel wires. So after you've built all of this, you can then test the generator using the different kinds of wire. So you take one of the iron rod cores that are like straight iron lines, and then you wrap the coils. You take that and you bend it in a U shape so that you're able to surround the magnetic rotor, so to speak, and get more movement in the wire from the magnetic field. And then using that method, I was able to collect data from all of those wire types and at different rotational speeds. So you can see the green line is the silver performance, and that one by far was the best out of all of them. You can see the other three, copper, steel, and aluminum, are all grouped down here from 350 to 750. They're very close in their performance, while steel remains a touch above the rest. After 750, though, and moving up to the 1300 rotations per minute, this is where the data gets interesting. While steel is a little ahead of copper, the two of them are like right together, very close. However, the aluminum seems to not improve much at all, which is very surprising to me because I figured that aluminum would at least hold even with them. And you can see that further demonstrated as it fails to grow at the rate that copper, steel, and silver do, moving up to 2900 RPM. Now, the other surprising part is that steel actually edges out copper in all of the categories, very slightly at the first, but then more obviously at the end. This was surprising to me because I knew copper was very conductive as a metal, so I was surprised to see that this steel outperform it. Now, one theory I have for why this steel performs better is because of the specific alloy. 316L stainless steel, while containing around 65% iron, contains almost 20% nickel, which is very conductive. My theory is that 20% nickel, and combined with the iron and other elements, allows it to stay ahead and edge out copper in total conductiveness. So, from this data, I concluded that my hypothesis was somewhat correct. The silver, like I predicted, commanded the lead, but steel was not the worst and, in fact, the second best. And an interesting fact to note is that steel is actually cheaper to produce than copper wire. So there's a potential alternative in the future if we run on low on copper or the price continues to increase, that steel could be used as an alternative wire material inside of generators because the US relies on a lot of power and you need more materials. So because of stainless steel's better performance, it could be an alternative. Interestingly, you can also see that the lines on the data are linear and not logarithmic as I predicted. Now, my reason for viewing this is that heat loss could not occur at such low RPMs. As you can see, I was only able to get 2900 RPM for my fastest cordless drill. So that was the peak of what I could achieve. And heat loss just did not occur at that point to the level where it sapped away any meaningful amount of energy from the system. And that's the reason that the lines are linear. So, to finish off, I believe that stainless steel, specifically 316L alloy, could could prove to be a very viable alternative to copper in using a generator.